Okay, this is Geometry 4.4, Congruence and Transformations. So one of the terms that you need to know are congruent figures. Congruent figures have to meet two requirements. They're the same size and the same shape. So you can have two figures that are congruent, such as two triangles. If these two triangles are congruent, not only are they the same size, they're definitely the same shape, but corresponding sides are congruent. For example, side PQ would be congruent with side TU. Side QR would be congruent with side UV. I'm just using tick marks here. And then side PR is congruent with side TV. Not only are the sides congruent, all the corresponding angles are congruent. For instance, angle P would be congruent with angle T. Angle Q is congruent with angle U. And then angle R is congruent with angle V. So all the sides and all the angles are congruent in each of the two congruent figures. Besides these two triangles being congruent, I could write what's known as a congruent statement. We might be getting a little bit ahead of ourselves, but we might as well get used to the correct way to write a congruent statement. So I could say that triangle, a little symbol for triangle, PQR is congruent to, and then I have to use the correct order. Notice that angle P is congruent with angle T. So I have to start with angle T or vertex T in the second triangle. Angle Q, the middle letter in this triangle here, or the middle vertex, is congruent to angle U. And then lastly, angle R is congruent with angle V. So triangle PQR is congruent to triangle TUV. I really should not write something like triangle PQR is congruent to triangle VUT because P doesn't correspond with or match up with V. Okay, and then looking at a couple of examples of congruent figures on problem number 1 says identify any congruent figures in the coordinate plane and then explain. What you might need to do for some of these figures, not all of them, is use a distance formula to be able to figure out if certain distances are the same. You might be able to just eyeball it as well, but there are a few different pairs of congruent figures in the diagram. I could say quadrilateral, EFGH is congruent to, I'm going to abbreviate here a little bit, quadrilateral. Notice I started with EF and then GH. So EF, that's 2 units long. That has to correspond with TU. That's also 2 units long. It could also correspond with or match up with VS. It can't match up with UV or TS because EF is 2 units long. UV and TS are each 1 unit long. But just to go in alphabetical order, EF and then TU, even though S comes before T, I really don't want to write it like that because ST doesn't correspond with EF. So quadrilateral, it could be something like TU, VS. It could have also been something like VS, TU. Those two quadrilaterals, more specifically rectangles, are congruent. Okay, and then I could also say quadrilateral MPON is congruent to quadrilateral ADCB or ABCD, kind of doesn't matter. Again, you could take a look. You could possibly use a distance formula to know that MP is congruent with AD and so on. And then lastly, we have two triangles congruent. Triangle JKL is congruent to J. That vertex or that angle matches up with P. So triangle P. K matches up with, or it's called corresponds with Q. And then L matches up with or corresponds with R. So those are the congruent figures in that diagram.